Hey guys, in this video we would understand different representations of a vector. Before going over the representations of vector, let's first understand how to draw a simple vector. Let's say if we need to draw a vector AB. A is where you're starting the vector from and B is where you're going to stop the vector at. Vectors are always drawn in the form of arrows. So the start point is represented as A. This is called the tail of the vector. Arrowhead is represented as B, as arrow is on the B part of the vector. So this is called the head of the vector. This is your head. This is the tail of your vector. Now the size of this AB is called the magnitude. Let's say we have a vector AB that is 5 centimeter in length and the direction is east. So how do we draw it? This is A and let's assume this means 5 centimeter. So arrowhead is on B, direction is going in east. Now if we want to draw vector BA, that is also 5 centimeter east, then this is how we draw it is B is now going to form the tail, A is going to form the head of the vector, and this is still 5 centimeter east. Let's say you're asked to draw a vector BA that is 5 centimeters west. Then B is still the tail. The first part of the vector is always the tail. The second part is always the head. So this is B, this is A, and this is 5 centimeters. Let's say we have to draw BA that is 10 centimeter west. All that we have to do is B is here and we just make the double of what we are making on the top. So this is BA vector with 10 centimeter as the magnitude. So always remember, when a vector is represented with two alphabets and an arrow on top of it, the first one is going to form the tail of the vector and the second is going to form the head of the vector. And the size of arrow is going to be equal to the magnitude of the vector. Now let's talk about vector representations. So vectors can be represented in two different spaces. One is called two-space vectors and one is called three-space vectors. Two-space vectors are the vectors that are represented only on x and y axes. Three-space vectors are the vectors that are represented on three axes, that is x, y, and z axes. So when it's three space, this is the x-axis, this is the y-axis, and this is the z-axis. So let's talk about two-space vector representations first. Now in two-space, vectors can be represented in these four different forms. One is vector drawings without grids. Second is vector diagrams with grids. Third is coordinate form. And fourth is magnitude and direction form. We can convert one form to the other. Let's take this form first. This is a simple form that we have already done. So the first is, if I want to write down vector AB in the form of a magnitude, so I'm just going to write down 5 kilometers is whatever is the unit. And then I mention the direction. So let's say I mention the direction to be north. This is my vector representation with a magnitude and direction. I can use this magnitude and direction to draw my second form, that is vector drawings without grids. So all I have to do is just start at my A and my arrowhead is at B. So this represents 5 kilometers vector AB in north direction. So first and the second type is done. Now let's go over the third type, and this is coordinate form. So let's say a vector A with lowercase a and arrow on top of it is written in the form of coordinates 2 and 3. So the first is the x value and the second is the y value. This is how we can represent a vector using coordinates. To draw vectors with grids, we can use this coordinate form of vector, and all that we have to do is just make a grid, because this is a two-space vector, so we would use x and y axes. X is 2, so we move, let's say this is 1, 2, and y is 3, so let's say this is 3. So x is 2, y is 3. That means on the x-axis we move 2, on the y-axis we move 3 units, and wherever we reach, that is going to form the arrowhead of the vector starting from the origin. So this is vector A. Because vectors are always drawn with arrows, so we make a tail, we make an arrowhead, and this is our vector. We can either write it as vector A or we can write it as vector OA. So this is how to represent a vector with coordinates on a grid. Now an important point to note here is that the vector given in coordinate form does not tell us what is the size of this vector. So if I want to find out the size of this vector, how do I do that? Size is nothing but the magnitude, and I can convert my coordinate form to magnitude form, and I can use my coordinates to find out the magnitude of the vector. And how is that done? Vector magnitude is represented with these two bars on each side of the vector. So if I put these two bars, that means I'm writing the magnitude of the vector, and I do not have to mention the direction of the vector. Now what do we have to do is just take the square of x, add it to the square of y, and square root it. So what is x squared here is 2 square, y squared is 3 square, square root it. We get 4 plus 9 square root, which is a square root 13. So the magnitude or the size of this vector here is square root 13 units. Now if we want to write down the direction of this vector, we can even do that. How to write down the direction? As we see here from these coordinates, we are able to get a right angle triangle, and direction is nothing but the angle with respect to the x or the y axis. So if I want to find this direction, all I have to do is just use tan theta. This is my y value, this is my x value. Y value is 3, x is 2. So to find out theta, all we have to do is just tan inverse of 3 by 2, which gives us 56 degrees. So now the direction of this vector is, this is the direction. Which direction I'm going is, I'm going 56 degrees north of east. So now if I want to write this vector in the form of magnitude and direction, so all I'm going to be doing is square root 13 units, and here I'm going to be writing with east I have angle 56 degrees in between north and east. This is the complete representation of my vector. So if we are given the vector in the form of coordinates, we can turn it into a diagram. So this is the diagram representation, and we can use it, either the coordinate form or the diagram form, to find out the magnitude of the vector and its direction. Now we'll be talking about three-space representation of vectors. Three-space means three axes, x, y, and z axes. When we have to do three-space representation, there are basically two ways. So two ways of representing vectors, and the first way here is vector diagrams on grids. Second is vectors can be drawn in coordinate form. So that is vector coordinates. Let's talk about vector coordinates first. So let's say we're given a vector A with, now it's going to be x, y, and z coordinates. So if you're given vector A as 3, 2, 1, that means x-axis you're going to move 3 units, y-axis you'll be moving 2 units, and z-axis you'll be moving 1 unit. We can use this to make our vector diagrams. So let's make the axes first. This is the x-axis, y-axis, and z-axis. Now because on the x-axis we have to move 3 units, so let's mark. Let's say this is 1, 2, 3. Let's say this is 1, 2, and let's say this is 1, 2, 3. So on every axis I'm marking 3 points. This is my origin. So I'm going to start from the origin always. From origin, I span on the x-axis 3 units. So I move towards the x-axis 3 units. And that means I reach here. Now, I have already moved on my x-axis. I have to move on my y-axis. So whenever I have to move on my y-axis, I don't stop here. I'm going to move from my point on the x-axis towards the y-axis and taking the magnitude equal to 2. So I'm going to move 1 and 2. How do I decide where to stop is, I'm going to make a parallel line to this x-axis from the y-axis point number 2. So this is where my point 3, 2 would lie. I have not yet taken into account my z value. My z value is 1. So I'm going to move 1 on So I'm going to move 1 unit on the z-axis starting from this point. And then how much would 1 unit be? How do I decide where to stop is from the y-axis I move towards my z-axis using 1 unit, and then I draw a parallel line to this. So if I see, I'll be able to basically draw a rectangle based prism passing through these points 3, 2 and 1. So where am I supposed to stop is I move 3 units on the x-axis, 2 units on the y-axis and 1 unit on the z-axis. So this is the final point where I stop. So my vector diagram is from origin to the final stop point, and this is my vector A. If we have to find out the magnitude, formula is the same, but here we have 3 axes, so we'll be using x, y and z. X square is 3 square, y square is 2 square, z square is 1 square, square rooted. We will have 9 plus 4 plus 1, which is 13 plus 1, which is square root 14 units. We do not have to worry about finding the direction in free space. All we have to worry about is just finding the magnitude. So this is how we use coordinates to turn it into a diagram, and also coordinates to find out our magnitude. Let's do another example for the sake of practice. Let's say we have a vector B represented as -1, 2 and 1. So we first draw the axes. Now remember here, this is the x value, y value and z value. So x value, we need negative axes. This is the positive x-axis. So the negative x-axis will be in the opposite direction. That would be this. We just need positive y-axis and the positive z-axis. So we do not have to make their negative counterparts. Now how do we start using these coordinates to turn it into a vector diagram? We would first move on x-axis starting from the origin, and we have to move -1 unit. So this is 1. This is -1. So we're going to move here and we're going to reach here. The next thing that we have to do is move 2 on my y-axis. So I'm going to be moving 2 on the y-axis. So if my y-axis, this is 0.1, 0.2, I'm going to be moving in such a way that I'm able to draw a line that is parallel from the y-axis to this. So I'm able to reach here. Now I've already spanned my x and y axes. I have to move on my z axis. This is 1, this is 2 on the z-axis. I have to move 1 unit from where I have reached previously, and that was here on the z-axis. Z-axis is upward, so I have to go up, up. And how do I decide the way I have to go up is because I'm here right now. From point 2 on the y-axis, I'm going to make a parallel line to z-axis, stop at 1. So this is how we make. This parallel line size and this size should be exactly same. How do we see that? This parallel line should be parallel to this. So this line should be parallel to this. Wherever we are able to draw a parallel line, that is where we stop. So if we try to complete this into a rectangle based prism, we would be able to get this kind of a shape. So make sure that we are able to get a rectangle based prism. So this is the point where we stopped. So this is the point where we stopped. We connect the origin to that point, and that is our vector, and this is vector B. Now if we have to find the magnitude of vector B, all we have to do is just take the square of the coordinates and square root it all. We'll be able to get 4, 5, 6, square root 6 units is our magnitude. And these are the different ways in which we can represent vectors.